Look up at the night sky. What do you see? Thousands of stars, each possibly with planets. We live in the Milky Way galaxy. It's a vast place, filled with billions of stars. We live on a planet called Earth, orbiting a star we call the Sun. Our planet is teeming with life. But what about those other stars? Do they have planets too? Could any of those planets be like Earth? For centuries, humans have wondered if we are alone in the universe. Finding exoplanets is no easy task. They are incredibly far away and small compared to stars. But scientists are clever. They've developed ingenious methods to find these hidden worlds. One method involves looking for tiny dips in a star's light. This happens when a planet passes in front of it, blocking a fraction of its light. Another method looks for wobbles in a star's movement. The gravitational pull of an orbiting planet can cause this wobble. These techniques have revealed thousands of exoplanets. Some are gas giants like Jupiter, but much hotter. Others are icy worlds, far colder than our solar system's frostiest corners. Among these discoveries, a few stand out as particularly intriguing. These are the exoplanets located in what scientists call the habitable zone. This zone is the sweet spot around a star. It's where temperatures are just right for liquid water to exist on the planet's surface. And as we know, water is essential for life as we know it. In 2015, astronomers announced the discovery of an exoplanet called K2-18b. This planet, about twice the size of Earth, orbits a red dwarf star about 124 light-years away in the constellation Leo. What makes K2-18b so special? It resides within its star's habitable zone, and scientists have detected water vapor in its atmosphere. This makes K2-18b one of the most promising candidates for life beyond our solar system. K2-18b is a super-Earth, a class of planets larger than Earth but smaller than Neptune. We don't have anything quite like it in our solar system. This makes K2-18b all the more fascinating. What is it like on the surface? What secrets does its atmosphere hold? These are questions that scientists are eager to answer. Our story begins not on a distant planet, but much closer to home. Imagine a telescope, not on Earth, but in space. It's called Kepler, launched in 2009. Kepler's mission: to find planets around other stars. How? By staring at a patch of sky, looking for tiny dips in starlight. Remember those transits? That's Kepler's specialty. Kepler was incredibly successful. It found thousands of potential planets, more than any other telescope before. But Kepler had a problem. Its pointing system was failing. Engineers on Earth devised a clever solution, using the pressure of sunlight to help Kepler stay steady. Kepler was reborn, its mission extended as K2. Even with its limitations, K2 continued to find planets. It observed a faint red dwarf star, catalogued as K2-18. This star, smaller and cooler than our Sun, would soon become very important. Why? Because Kepler, in its tireless search, detected a telltale dip in the light coming from K2-18. Something was orbiting this distant star. Back on Earth, scientists analyze the data from Kepler. They study graphs of starlight, looking for those tiny dips. The dips are minuscule, requiring sophisticated computer programs to find. But there it was, a clear signal. A planet was crossing in front of K2-18, blocking a tiny fraction of its light. This new planet was designated K2-18b. It was the 18th planet found by the K2 mission around this particular star. Excitement rippled through the scientific community. Here was a planet, orbiting a star in the constellation Leo. A star not too different from our own Sun, but much smaller and cooler. The discovery of K2-18b was just the beginning. Astronomers wanted to know more. How big was this planet? What was its atmosphere like? Could it perhaps harbor life? The hunt for answers was on, and a new chapter in the story of K2-18b was about to be written. Determining the size of a planet billions of miles away is no small feat. The amount of light blocked by the planet tells us its size. In the case of K2-18b, the dip was significant. K2-18b is twice the size of Earth and 8 times more massive. This places it in the intriguing category of super-Earths. What kind of world was K2-18b? The answer lay in further observations. But the story doesn't end there. As astronomers continued to study K2-18, they found something else. Another dip in the starlight. Another planet. This one, dubbed K2-18c, was also orbiting the red dwarf star. But unlike its sibling, K2-18c was much closer to its star. This close proximity meant that K2-18c was likely a scorching hot world, inhospitable to life as we know it. Its year, the time it takes to orbit the star, was a mere 9 days. Imagine that. A year that's less than 2 weeks long. While K2-18c captured the imagination, it was K2-18b that held the real promise. The discovery of K2-18c highlighted the diversity of planetary systems. It also underscored the importance of finding planets in the habitable zone, like K2-18b. With 2 planets now known to orbit this distant star, the K2-18 system became even more intriguing. It was a glimpse into another solar system, one that might hold the key to answering one of humanity's most profound questions. Are we alone? Let's talk about the habitable zone. Imagine a zone around a star where the temperature is just right. Not too hot, not too cold. Like Goldilocks and the porridge, just right for liquid water on a planet's surface. K2-18b orbits within this magical zone around its star. Remember, K2-18b is a super-Earth. It's bigger than Earth, but smaller than Neptune. This puts K2-18b in a unique category. We don't have any super-Earths in our solar system. This makes K2-18b all the more exciting to study. What could it be like on a planet this size? The habitable zone is a good starting point for the search for life. But it's not a guarantee. A planet needs more than just the right temperature. It needs an atmosphere for starters. And not just any atmosphere, but one that can protect life from harmful radiation and provide the right ingredients for life to thrive. Imagine a telescope so powerful that it can analyze the light passing through the atmosphere of a planet trillions of miles away. That's what astronomers used to study K2-18b. They used a technique called transit spectroscopy. It's like looking for fingerprints, but instead of fingerprints, they're looking for the signatures of different molecules in the planet's atmosphere. And what did they find? Water vapor. Yes, you heard that right. Scientists found evidence of water vapor in the atmosphere of K2-18b. This was a huge discovery. Water is essential for life as we know it. It was the first time that water vapor had been detected in the atmosphere of a planet orbiting in the habitable zone of its star. This discovery sent ripples of excitement through the scientific community. It meant that K2-18b was not just a potentially habitable planet, but one that might actually have the conditions necessary to support life. The presence of water vapor opened up a world of possibilities. Picture this, a planet covered entirely in water. No continents, just a vast, global ocean stretching as far as the eye can see. That's one possibility for K2-18b. With its size and the presence of water vapor in its atmosphere, it's entirely plausible that K2-18b is a water world. Or perhaps K2-18b has a more Earth-like configuration, with continents and oceans. Imagine islands dotting a vast sea, with clouds swirling overhead. Could there be life teeming beneath those waves, or even on the land itself? The possibilities are endless, and they're enough to make even the most skeptical observer dream of alien life. Of course, these are just educated guesses. We don't yet have the technology to know for sure what lies beneath the clouds of K2-18b. But the very fact that we're asking these questions is a testament to how far we've come in our search for life beyond Earth. The puzzle of density, rocky planet, or gaseous Mini-Neptune. K2-18b is bigger than Earth, but what is it made of? Is it a rocky planet with a solid surface, or a Mini-Neptune with a gas envelope? The answer lies in its density. Density tells us how much mass is packed into a given volume. Tidal locking. One side in perpetual daylight, the other in darkness. Imagine a planet where one side always faces its star, bathed in perpetual daylight, while the other side remains shrouded in eternal darkness. This is the strange reality of tidal locking. The ingredients for life. What we look for beyond Earth. We search for life beyond Earth. But where do we even start? What makes a planet potentially habitable? Scientists focus on key ingredients. Think of it as a recipe for life, a cosmic cookbook of sorts. First on the list, liquid water. We haven't found life as we know it that can exist without it, but water alone isn't enough. Life needs energy. On Earth, the sun provides that energy. Plants use sunlight to make food, and animals eat plants, or other animals that have eaten plants. This transfer of energy powers the entire biosphere. So, a habitable planet needs a source of energy, whether it's from its star or perhaps even internal heat. Next up, the right chemistry. Life on Earth is carbon-based. Carbon is a versatile element, able to form complex molecules like proteins and DNA. So, we look for planets with carbon or other elements that could support similar complex chemistry. Water, water everywhere. The importance of liquid water. Why is liquid water so important for life? It's all about the chemistry. Water is a fantastic solvent. This allows for complex chemical reactions necessary for life. Think of water as the stage for life's dance. It actively participates. It transports nutrients and removes waste. It's vital for countless biological processes. Without liquid water, life would grind to a halt. The presence of water vapor in K2-18b's atmosphere is exciting. It suggests liquid water could exist on the surface. Section 3. The right stuff. Searching for biosignatures in K2-18b's atmosphere. Imagine trying to understand the hustle and bustle of a city, but all you have to go on is the faint glow of its lights from afar. That's the challenge astronomers face when studying exoplanet atmospheres. But even from this faint glow, we can glean valuable information. Certain molecules in an atmosphere absorb light at specific wavelengths. By analyzing the light that passes through an exoplanet's atmosphere, we can identify these molecules and learn about the planet's composition. Some molecules, known as biosignatures, are considered to be strong indicators of life. Oxygen is a prime example of a biosignature. On Earth, oxygen is constantly replenished by photosynthetic organisms. Without life, oxygen would quickly react with other elements and disappear from the atmosphere. So, finding significant amounts of oxygen in an exoplanet's atmosphere would be a major clue that life might be present. Section 4. The Red Dwarf Dilemma. Challenges for life around K2-18. Red dwarf stars are the most common type of star in the Milky Way. They're smaller, cooler, and much longer lived than our Sun. This means that planets orbiting red dwarfs have plenty of time to develop life. But there's a catch. Red dwarfs are also known for their powerful flares, sudden bursts of energy that can be harmful to life. These flares can strip away a planet's atmosphere, leaving it vulnerable to the harsh radiation of space. Imagine a sunbath that could turn deadly in an instant. K2-18b orbits its red dwarf star very closely. This means that it's likely tidally locked, with one side always facing the star and the other in perpetual darkness. The planet is also bombarded by much stronger radiation than Earth receives from the Sun. These factors could make it challenging for life to arise and thrive on K2-18b. Despite the challenges, we can't rule out the possibility of life on K2-18b. Life is incredibly resilient and adaptable. We've found organisms thriving in some of the most extreme environments on Earth, from the depths of the oceans to the driest deserts. Perhaps life on K2-18b has found a way to cope with the intense radiation and tidal locking. Maybe it exists in the planet's oceans, shielded from the worst of the star's outbursts. Or perhaps it has evolved to thrive in the narrow band of twilight between the planet's day and night sides. The truth is, we simply don't know what's possible. The universe is full of surprises, and life has a way of finding a foothold in the most unexpected places. Until we have more data, the question of whether or not we're alone will remain one of the most profound and enduring mysteries of our time. Our eyes on the cosmos are telescopes. They extend our vision across unimaginable distances. They gather light, those faint whispers from distant worlds, and they tell us stories written in the language of stars and planets. To unravel the mysteries of K2-18b, we rely on these powerful instruments. Some are Earth-based, giants with mirrors that capture starlight from remote mountaintops. Others, like the Hubble Space Telescope, orbit above Earth's atmosphere, providing a crystal-clear view of the cosmos. Each telescope brings unique capabilities to the table. Some are designed to study a planet's size and orbit. Others analyze the composition of its atmosphere, searching for those telltale fingerprints of molecules. It's a collaborative effort, with telescopes around the world and in space working together to paint a more complete picture of this intriguing exoplanet. For decades, the Hubble Space Telescope has been our eye in the sky. It has revolutionized our understanding of the universe, from distant galaxies to planets within our own solar system, and it has played a crucial role in studying K2-18b. In 2019, Hubble made a groundbreaking observation. It detected water vapor in the atmosphere of K2-18b, marking the first time this had been achieved for a planet orbiting in the habitable zone of its star. This discovery, a testament to Hubble's remarkable sensitivity, sent ripples of excitement through the scientific community. Hubble's observations of K2-18b didn't stop there. The telescope has also been used to study the planet's atmosphere for signs of clouds and other atmospheric features. These observations provide valuable clues about the planet's climate and potential habitability. The James Webb Space Telescope, a new era of exoplanet exploration. In December 2021, a new era of astronomy dawned with the launch of the James Webb Space Telescope, or JWST. This revolutionary telescope, with its giant gold-coated mirror and advanced instruments, promises to revolutionize our understanding of the universe, including exoplanets like K2-18b. JWST is specifically designed to study the atmospheres of exoplanets in unprecedented detail. It can detect the faintest signals from molecules in a planet's atmosphere, providing a more comprehensive inventory of its composition than ever before. Imagine a detective using a magnifying glass to scrutinize every detail of a crime scene. With its powerful capabilities, JWST is poised to unlock even more secrets about K2-18b. Scientists are eager to use JWST to search for additional biosignatures in the planet's atmosphere, such as methane, which could provide further evidence for the possibility of life. Beyond the horizon, future missions and the search for life. The quest to understand K2-18b is far from over. While Hubble and JWST provide invaluable insights, future missions are already on the drawing board, promising even more detailed observations of this fascinating exoplanet. These future missions might include space telescopes specifically designed to study exoplanet atmospheres, or even ambitious missions to send probes to directly study these distant worlds. Imagine a future where we can analyze samples from K2-18b's atmosphere, or even its surface, searching for definitive signs of life. The search for life beyond Earth is a journey of discovery, a testament to our innate curiosity and our desire to understand our place in the cosmos. With each new observation, each technological advancement, we inch closer to answering one of humanity's most fundamental questions. Are we alone? And K2-18b, with its tantalizing hints of water vapor and its potential for harboring life, stands as a beacon of hope in this grand cosmic quest. The discovery of K2-18b marked a pivotal moment in our exploration of the cosmos. Twice the size of Earth, it orbits a red dwarf star over 100 light-years away. Residing in the habitable zone, it could have liquid water. The detection of water vapor in its atmosphere was groundbreaking. K2-18b became a prime target in the search for life beyond Earth. Its discovery underscored a profound shift in our understanding of the universe. It fueled our determination to develop more powerful telescopes. The quest to understand K2-18b extends beyond the search for extraterrestrial life. It's about unraveling the story of our universe, written in the language of stars and planets. Studying exoplanets like K2-18b helps us understand how planetary systems form and evolve. Each discovery adds to the cosmic puzzle, refining our models of planet formation. We learn about the diversity of worlds beyond our solar system. Discovering planets in bizarre configurations challenges our notions of solar systems. We gain a deeper appreciation for the conditions that make life on Earth possible. The exploration of space has always captivated the human imagination. From the earliest stargazers to the astronauts who walked on the moon, we have an innate desire to push the boundaries of our knowledge and explore the unknown. The study of exoplanets like K2-18b carries on this legacy, inspiring future generations to reach for the stars and unravel the mysteries of the universe. The quest to understand K2-18b and other distant worlds fosters a sense of wonder and curiosity, encouraging young people to pursue careers in science, technology, engineering, and mathematics, or STEM. It highlights the importance of international collaboration and the power of human ingenuity to overcome technological challenges and achieve ambitious goals. By investing in space exploration and scientific research, we not only expand our knowledge of the universe, but we also inspire innovation, drive technological advancements, and create a more scientifically literate and engaged society. We empower future generations to build upon our current understanding and continue the journey of cosmic exploration for centuries to come. As we stand on the precipice of a new era of astronomical discovery, with powerful telescopes like JWST and its successors peering deeper into the cosmos, the possibilities for unraveling the mysteries of K2-18b and other exoplanets seem limitless. We may one day detect definitive signs of life in the atmospheres of these distant worlds, or even send probes to directly study their surfaces and oceans. The journey to understand our place in the universe is far from over. It is a journey that will continue to challenge our assumptions, expand our horizons, and inspire us with the sheer beauty and wonder of the cosmos. And as we continue to explore the universe, we do so with a sense of awe, humility, and a deep appreciation for the interconnectedness of all things. The universe awaits, and our voyage among the stars has only just begun.